Hello everybody and welcome to this tutorial kind of thing that I decided to do today / now. We are going to talk about binary and how to read it as a decimal, and what you should know, decimal means number basically. So what I'm going to do is just going to open text edit there. I have my dock over here, but I don't like having a dock, so I just made it really small and just use Alfred or Spotlight to open my programs. But anyway, let's just open this. No, I prefer it windowed. Just make it a tiny bit bigger. Anyways, okay, so binary. Where is format? Make plain text, hopefully. Yep. Right then, let's just make everything slightly bigger. That'll do. Okay then, so basically binary is ones and zeros. You got your ones, you got your zeros, and they go together to make binary. Ta-da! Now, in binary, there are things known as binary digits. I think it's binary digits. So a binary digit is called a bit, right? And a bit is one binary digit. It's just a 1 or a 0. You know, that's just a bit. One part is a bit. I'm going to move this down a bit. See what I did there. Anyway, so that's a bit. That is also a bit. And if you have 8 of them, it makes a byte. So 1, 2, 3, 4, 5, 6, 7, 8. That is a byte. Okay, a byte is 8 bits. Now, I'm not going to go into bytes and megabytes and gigabytes and what's after terabytes, petabytes. What's after peta? I can't remember, but I know there's such thing as a yottabyte, which is huge. Anyways, so reading binary is not as hard as you may think, because it's just really quite simple. What you do is you just separate it out. I mean, binary, if from a human's perspective, is read from right to left, but of course from a computer's perspective is reading from left to right. But it is really quite simple, because binary is set out that each bit is representative of a number, and that number is defined by its place. So in a 4-bit number, let's just put a, I don't know, random 1 0 0 1 0. Okay, let's go up to here. Now, in the first column, from the right hand side, from the least significant bit, the LSB, this one here, this one is worth 1. Okay, so let's head here. This bit here, the next one along, is worth 2. So let's go on again. This bit here is worth 4. Okay, this bit here is worth 8. And depending on the size of your bit depth, you know how many bits there are, it just keeps doubling. So it starts at 1, it doubles, 2 doubles, 4 doubles, 8, after that is 16, after that is 32. You know, it's just really simple. And to work out the number that 1010 represents, is you just add the ones up, because a 1 and a 0 are, let me just even this out, a 1 and a 0 are just basically states. So a 1 equals yes, a 1 equals true, a 1 equals hit, I don't know. What else could I say? A 1 equals positive. Hopefully I spelled that right. Okay, and a 0 basically is the opposite. It means no, it means false, it means miss, it means negative. Well, not really. Those two are a lie, I guess, because we're going to positive and negative numbers in another video. But anyways, to work this out, you just say, okay, 1. Is there anything in 1? There's a 0 here, which means no, so there are no 1s. So the number ends up being all of these added together. So number 2, it has a 1. That means it is present. So it will be 2 add 4. It is not present, not there. And 8, it is present, so it is there. So this would equal 10. See what I'm doing here? Let's go a little bit more in depth. Let's get rid of this. Let's have a byte. This is a byte. there we go. A byte is 8 bits, remember? This is 8 bits. And let's just say, I don't know, 1 tab, 0 tab, 1 tab, oops, tab. Oh, these aren't going well. Gonna have to do some spaces to make these align. Here we go. Let's do tab 0. Okay then, so let's work out this one. Okay, where's my mouse? There it is. We have 1, not present. 2 is present, so we have 2. 4, not present. 8, it is present. It's like doing a register or something. 16 is present. 32 is not. 64 is. 64. 128 is. And then you just add all these up. So you've got 10 here, 36. So that ends up being 218. And of course, there are limits to binary numbers, such as you cannot represent 1,000 with a 4-bit number, with just these here, because 8 add 4 add 2 add 1 does not equal 1,000, not even close. You have to have more bits in order to do that, and a byte, if you add all these up, comes to 200 and something. This is a good opportunity to explain how you work out the maximum bit depth as to what a binary can do. So you've probably seen the pattern here, right? It doubles. I've explained it. It doubles every time. So what you're going to have is you're going to have 2 to the power of your bit depth, which is b. 2 to the power b. So what we've got here in an 8-bit number. Oh wait, let me just go here. A -1. Okay, so damn it. What we've got here is 2 to the power b -1. So that would, for an 8-bit number, you've got 2. I don't know how to do superscript. You can't do superscript in text edit. Damn it. Okay. 2 to the power TTP. 2 to the power 8 -1. And those of you that don't know, 2 to the power 8 is basically 2 times 2 times 2 times 2 times 2 times 2 times 2. What's that? 1, 2, 3, 4, 5, 6, 7. Yeah, one more. Times 2. Yeah, so it's really simple, and then you will have the maximum number of your bit depth. So whatever this is, the maximum. If this was all ones, if these were all present, that would be your answer. So let me just work this out. Okay, I should have memorized this because it's really easy. It's 255. So that is your maximum bit depth of a byte. And that's all there is to it, really, for reading binary as a number. In the future, I will go into negative numbers and such, and then maybe into letters. But for now, this is all you need to know. And thanks for watching.